This video is all about finding the range of a function using your graphical calculator. Now, you should already have watched the main video on finding the range so that you know what it is and how to sketch the graphs without your calculator, because there will be some examples that you can't use your calculator for. And so you should have already seen the key steps here, where the first thing is to draw a sketch and think about the domain of the function, so what x values you're considering. The next step is to look at the y-axis and to think about what the largest the y value can be and what the smallest the y value can be in that domain. And then step 3 is to write that as an inequality for y or f of x and think about whether it can be equal or not to those values. The examples we're going to do are the same ones from the previous video, but we're obviously going to be doing this with a graphical calculator. So these are the 5 examples we're going to be looking at. We're going to look at y equals x squared minus 4x plus 2, where the domain is that x is between 0 and 5. So that's the first one we're going to look at. So on your graphical calculator, what you want to do is you want to go to the main menu and you want to select option 5 for drawing graphs. You then want to input the equation, so you can see there that I've inputted y equals x squared minus 4x plus 2, and then you want to select the draw option. Let me just show you that very quickly where that is. That, just in case you can't see it, is there. So you want to press this button here to draw that graph. You should get this option here. This is what it should look like. At the moment, your scale might be a bit funny. To adjust your scale, you want to click the V window button, and that will allow you to change the scale on your axes. Come and see me if you need me to show you how to do that. Then the next thing you want to do is click the trace button. Now what that will do then is take you to this, where it will show you a point on the curve here and its x and y coordinates, the x and the y coordinates. You can see they're also given at the bottom there. And what you can now do is you can use the pad here to scroll along, and it will show you all of the different x and y coordinates of the points that are on that curve. Right, so let's have a look at how we can find the range from this. So I'm just going to go to my program, which I'm going to be using Desmos to do this. So this is my equivalent of your graphical calculator. So you can see I've got my y equals x squared minus 4x plus 2 graph there. And if I just pick a point, you can see here it's showing me the coordinates. So at this point here, the x coordinate is roughly about 0.36, and the y coordinate is about 0.69. And as I move along here, we can see how the x and the y coordinates are changing. So you would be doing this just on your graphical calculator. Now remember that the domain of this function was between 0 and 5. So we're not interested in any of these values over here because the x coordinates are negative down here. The smallest the x coordinate we're interested in is 0, which is here. So that's the coordinate 0, 2. So the y coordinate is 2 at that point. You could also find that 2 by just substituting 0 into the original equation, the equation of the function. So y is 2 here, and then we can see that y goes down, down, down. Y is decreasing, we're into the negatives now. And then at this point here, the y coordinate is minus 2. And then the y coordinate starts increasing again. It goes up and up and up. Remember, we're only going up to when x is 5. And we can see at this point here, x is 5, y is 7. And again, if you weren't sure about that, you could substitute 5 into that original function and you would get 7. So what's the biggest that y can be when we are in between x is 0 and x is 5? Well, the biggest that y can be is 7 at this point here. The smallest that y could be is minus 2 at this point down here. That's the smallest the y coordinate can be. So the smallest that y can be is minus 2. The biggest it could have been is 7. So we're going to write that down then. I'm going to say that y has to be bigger than minus 2 and less than 7. And now I just need to think, should I have lines underneath here or not? Could it equal minus 2? Well, yes, it can equal minus 2. Because we saw that the y coordinate does equal minus 2 in that domain when the x coordinate was 2. However, if I was to put this line here, that would be wrong, because the x coordinate equals 7 when the y coordinate equals 7 when the x coordinate was 5. And we can see that there is no line underneath the 5 there. X can't equal 5, so therefore y can't equal 7. So that is how I'm going to leave my answer for the range. You could also, instead of putting y there, you could put f of x like that. So that's my answer for the first question. Let's have a look at the next one now. Okay, so here's my graph of 2e to the power x plus 3. And there is no restrictions on the domain in this question. So let's have a look. Let's have a look at some points here. You can see it's cutting through the y-axis there at 5. And I can see that y gets up bigger and bigger and bigger and bigger. It's going up and up and up. And in fact, it is always going to keep going up and up. There's no upper limits to what y can be here. In terms of lower limits, we can see that it gets smaller and smaller. We've got 3.5, 3.4, 3.3, 3.1, 3.08, 3.03. It's getting closer and closer and closer to 3, but never actually touching 3. Getting closer and closer and closer, but you can see it's never actually going to touch 3, and that's because 3 is the asymptote. So I can say that the y coordinate here has to be bigger than 3. Has to be bigger than 3. So to write my answer down, I'm going to say that y has to be bigger than, and it can't equal 3. There's no upper limit in this case, so I could write that the other way around just to be consistent actually. So y has to be bigger than 3, and there's no upper limit. Can't equal 3 because 3 was the asymptote. And again, I could replace the y with an f of x if I wished. Next example. We've got 2 to the power minus x minus 5, which looks like that. And we were looking in the domain of x is greater than 1. So we only want where x is bigger than 1 here. So all of these values down here where x is negative, I'm not interested in any of these. I'm only interested in where x is 1 here. Now I can see when x is 1, x is minus 4.5. And we can see that that's going to be the biggest that it can be in this domain here. If you wanted to work that out algebraically, we could substitute 1 into that function. So 2 to the power 1, 2 to the power minus 1 minus 5, and that will give you the y coordinate. After that point, we can see that y gets smaller and smaller and smaller. It's tending towards minus 5. You see it's getting minus 4.9, 4.97, 4.98, and so on. It's getting closer and closer and closer to minus 5, but never actually touching, which makes sense because of the minus 5 asymptote. So I can now say that the y coordinate has to be bigger than minus 5. It can't equal it, because that was the asymptote. And it has to be less than the minus 4.5. It can't equal the minus 4.5 because x can't equal 1. Again, if you're not sure where the minus 4.5 came from, that was just me substituting 1 in here. And again, we could write f of x instead of the y function there. Next example, 6 over x plus 1. And we're looking in the domain where x is greater than 3 here. So I'm only looking for where x is greater than 3. So that's why I'm ignoring all those negative coordinates. I'm ignoring these coordinates here where x is less than 3. So when x is equal to 3, y is equal to 3. Again, you could find that out by just doing 6 divided by 3 plus 1. So that's the biggest that it can be, 3, because when I make x bigger than 3, we can see the numbers get smaller and smaller and smaller. It looks like it's tending towards 1 here. Let me just zoom out a little bit. Yes, we've got, here's 2, 1.9, 1.8, 1.7, 1.6, 1.5, 1.4, 1.3, 1.2, and yeah, it's tending towards that asymptote of 1. See, yeah, it's getting closer and closer and closer to 1. So, I can say that my range for this, f of x, it has to be bigger than 1. It can't equal 1 because 1 was the asymptote, and less than 3. Again, it can't equal 3 because there's no equals in the domain here. If there was a line underneath here, then I would put a line underneath here like that. Last example. Okay, so we've got the graph of 4x plus 1 over 2x minus 3, and we're looking at this in the domain of x being greater than or equal to 3. So x is equal to 3. Here, that looks like 4 1/3 to me. Again, you can work out that by substituting 3 into your function, and it will tell you the y coordinate. So doing 4 times 3 plus 1 divided by 2 times 3 minus 3. And that's going to be the biggest that it can be in this domain, because when x gets bigger than 3, we can see y gets smaller and smaller and smaller. It's tending towards 2, I think. You can see it's 2.8, 2.7, 2.4, 2.3. It's getting closer and closer and closer to 2. It looks like 2 is the asymptote, I think. So I can say that y has to be, let me just remind myself what it was at the beginning. It was 4 1/3, so less than 4 1/3 and bigger than 2. So f of x has to be bigger than 2 but less than 4 1/3. In this case, it can be equal to 4 1/3 because we have x can equal 3. It can't equal 2 because 2 was the asymptote. And there we go. That is how you can find the range of a function by using your graphical calculator.